Again, just to reiterate,
Also,
input needs to be time in this context.
300.
15 seconds works, 84.5 seconds works. 300 seconds equals like how many minutes though?
It's
300
5.
seconds is about a minute and 40 seconds.
It's about 5 minutes.
Minute and 5. Wait. You're right.
It's by about 5. It is 5. So that's too much, right? That's too much because we're only 3 minutes. So let's talk about outputs. So outputs in this case, time goes in, what comes out? Barks. So can you have 15 barks? Can you have 84.5 barks? Can you have 300 barks? Yeah, that means 100 barks per minute. I bet you a dog could do it. That's less than 2 per second. I had a 6th grader first hour prove it's possible.
I don't think a dog can work that fast.
What you have here is you have a situation where you have inputs and outputs for a side of a square and the area of the square. You're going to get this set of numbers that I have in my hands, and it's your job to say which of these are possible to be inputs and which ones are not possible to be inputs. So in your math notebook, 2 columns, possible and impossible. All right, so looking at this list, here's what I got for possible inputs from your card list. I got that 9 works, 3/5 works. Yeah, you can have a set. 3/5 times 3/5, you can do that. 15, 0, 0.8, 4, 25 fourths, 0.001, 6.8, and 72. Then,
Zero would be the zero would
that'd be a square with an area of 0. Then, the inputs I got that do not work were -3 and -18. I get why some people are saying 0, but 0 squared is 0. So a square with a side length of 0 has an area of 0. So what I want to do is get some language for like all the possible inputs and then all the impossible. So what's something that we notice about all possible inputs? Yep. They're all 0 or positive.
Isn't technically 0
Okay.
not even?
And then all of the impossible ones were negative. You can't have negative side length.
Isn't 0?
Okay, cool. We're going to try this with a new circumstance. This is a tennis camp. They charge $40 per kid. They will not run tennis camp unless they have at least 5 campers, and they can't have more than 16. I want you to look at your numbers and give me a list of possible inputs and outputs from your list. Possible and impossible inputs only. Let's go. So looking at our inputs from your list, I only found 2. Who can give me the inputs that work? Finn? 9 works. There's one more. What's the other one? 15. And so the only reason these are the only ones from your list to work is what kind of numbers cannot work?
Anything less than
Heavens.
Anything negative, anything that's a decimal, anything that is less than 5, or anything that is more than 16.
So negative, fractions, decimals. And then for the input, right, you have to have anything less than 5 doesn't work. And anything more than 16 doesn't work. It can't be negative, can't be a fraction, can't be a decimal. Instead of listing all those, we're listing the attributes.
More than 15.
Yeah, more than 15 or 16. Okay, yeah, that's better wording.
anything more than.
More than 15, I like that.
No, because no.
But it allows.
Oh wait, no, it's 16. That was right.
16 is included to.
More than 16. That does work. That does work. Grant,
16 is allowed, but 15 is.
I'm sorry, I thought I saw it just slip.
if you're missing an arm, you're still a full person.
I told you, Grant.
I'm glad we could clarify that. All right, last one.
What if you're.
This is temperature, Kelvin and centigrade. You can get to Kelvin by taking centigrade and adding 273.15. Does anybody know the significance of Kelvin? It's actually used in science a bit.
Yes, it's for like, isn't it like?
I don't know what it is.
Kind of 0 Kelvin's kind of famous.
0 Kelvin is absolute 0. And other than
Yeah.
that, it's the same as 6.
Yep. So 0 is absolute 0
Means
in
that
Calc.
like the molecules are not. That should make.
So for this one,
If not,
all real numbers. However, negative 273.15 or more. You can't get colder than 0 that I'm aware of. So, but in your set of numbers, it's all the numbers, right? They all work. Negatives work. There's negative temperatures. Positives work. There's positive temperatures. There's fractions of temperatures. All of the rest of your numbers work, and they work well.
What's impossible? And you guys
Not any.
Less than this, because as far as I'm aware, which I'd have to maybe do some more research, I don't think they get colder than absolute 0 because
I don't even.
there's no other way to lose any more energy to get colder. So.
You just wanted to find something.
I don't know if you noticed, but we keep talking about inputs. When we come up with these sets of numbers that work for the input, that is called the domain. The domain is all possible inputs. So that's why I was kind of getting at those more general statements we were making. Depending on context, some inputs don't make sense. For example, on an iTunes gift card, and you're trying to buy songs, is an input of 2 2/3 songs. Does that make sense in context? So then fractions and decimals in your iTunes would inputs of songs to buy could not be anything but whole numbers and positive whole numbers, right? No integers. So since we're talking about inputs, guess what we're going to talk about now? Output. So we're back to the square here. You can see there's a graph of the square. Input for side length, output area. I'd like you to list 3 possible input-output pairs, and then describe what all the outputs would look like. So you're going to make that statement that would give us all the outputs. It gives you the input statement to help you if you want. With your partner, about 1 minute, 30 seconds. All right, who's got a possible input-output pair for me? Eliana. It actually be 2, 4. 2, because 2 goes in, 2 squared is 4. Right there, we found it.
4 1.
Elliot.
416.
416 right there. All right, Hadley.
0, 0.
0, 0 right there at the origin. One more, Juliet. 3, 9 right there. And then there's all those. The reason this is connected, right, continuous, is we can have fraction and decimal side lengths of a square. So that's a continuous graph. All right? And who can give me a statement then that would tell us if all of our inputs are 0 and everything greater,
Wait.
what could you say about the outputs or the y values? What do you notice, Finn? Any number greater than?
It seems like it's a square.
Or equal to 0. Because the lowest thing that could go for the input is 0. 0 squared is 0. Then the next thing, 1 goes in, 1 comes out. 2 goes in, 4 comes out. So it doesn't say make a rule for the output. It says what numbers could they be? Anything 0 or greater.
If you want to use fancy math.
Let's keep practicing these outputs. So your job, this right here is for the tennis camp. You need to decide which graph is the correct graph, and then explain the outputs. Come up with a statement for all possible outputs. Let's take a vote. Who's got the graph on the left? Who's got the graph on the right?
Wait, sorry, I forgot my left.
I picked this one.
Yeah.
And who can explain why we would need to go with that graph? Ashley?
Because it starts at 5 and ends at 16.
So it starts at 5, ends at 16. Those are the possible number of players. Yep. Raymer, why else?
Because you're going to have a partial person.
No partial person inputs, okay? Let's say you're at this tennis camp, you got no arms, you're still a one person.
How would you? What if you're at?
I'll leave that up to your imagination, but either way, you're still a full person. Is 20 a possible output? No. What's the lowest output we could have?
200.
So 20 is not an output. What about 100? No. Because the reason why is $40 per person, you need at least 5 people. So the minimum is 200. I'm going to write that down here. Minimum of 200. Okay, and then does it just go on forever?
No.
After the minimum of 200, what has to happen?
16 times 4. It's like
So maximum of 640. And is it all values in between?
Yes. No. Fraction.
It has to be.
Numbers.
It's any multiple of 40.
Whole
It
numbers.
needs to be multiples of 40. And why does it need to be multiples of 40?
Because you can't have a partial person.
Every additional person, $40.
Oh, couldn't it be like 40 times 0.5 though?
Yeah, but you can't have a half person. So this is just outputs. If we have 5 people, it's $200. If we max out at 16, we have 640. And every multiple of 40 in between is all of those people that could be the answer. So all those outputs we're talking about now, we call those the range. It just means all possible outputs, or the set of all possible outputs. So if there's 2 things, domain, which is all possible inputs. Range is all possible outputs. And you could like maybe mix those up, right? With one thing that's kind of cool, they go in alphabetical order, X, Y, just like X, Y do. So domain is possible X values, range possible Y values. All right, let's make sure. We know what's meant by domain and range then? Check. When we have a description, can you pick out what things can go in and what things can come out? Yes, we can. You are going to do a lesson summary.